We use scale drawings and scale models all the time, especially in the areas of science, because we cannot always see something because it is either very big or very small. For example, we can't really see our cells. If you just look at your hand, you can't see the cells that it is made up of. But in your science textbook, you will see lots of drawings that look like this, and actually you will be creating three-dimensional models of cells using food that would look like this. So we use scale drawings and scale models when objects are either too big or too small to be seen easily. A scale drawing is a two-dimensional drawing that represents a real object. So this would be a flat drawing of a cell that is labeled. And a scale model would be a three-dimensional representation, so something you could actually hold in your hands that represents a real object. Scale is written as a ratio, and it is always shown as the model to the actual. You could see it using the colon, 1 inch is 2 miles, or you could see it with an equal sign, 1 inch is 2 miles. And on all maps, you will see a scale so that you could figure out the actual islands, these islands down here in the Bahamas, you could figure out how long these islands are from end to end using this scale. You could be asked to find the scale of something. There was a drawing of the Titanic, and the Titanic drawing was 12 inches, but the real Titanic was 882 feet. So if we wanted to find what the scale is, let's refresh our memories really quickly. The model in relation to the actual is what we're looking for. So the model in relation to the actual. Or in other words, 12 inches was equivalent to 882 feet. Now, if I go back to this map, I can see that this isn't measured in 882-inch increments. And in these examples, I'm saying 1 inch is 2 miles. So we should really kind of make this a little bit better. So I'm going to set it up like this, 12 inches and 882 feet. I really would kind of want to know, well, not 12 inches, but on a drawing, what would 1 inch represent? And now this is something that I can solve. This is a proportion I can solve. I'm going to divide the top here by 12. 12 divided by 12 will give me 1, which means I'm going to have to do that same division on the bottom to come up with this. I'd like you to finish this scale calculation, and that will tell you what the scale of this drawing is, and your answer will say 1 inch equals blank feet. We can also use scale to solve problems, like in this example of a blueprint. Blueprints are used to show what a house will look like before it's built. This is an example of an elevation drawing, what the outside of the house will look like. And this particular blueprint, you couldn't see the scale, so I wrote it for you here. On this particular blueprint, 1 inch is 42 inches in real life. So on this blueprint, how tall is a door that would be 2 inches on the blueprint? Well, let's go ahead and set up a proportion. And I'm going to remember that my scale is shown as the scale to the actual. So I'm going to label scale. I'll put all my information about the scale on the top and all the information about the actual drawing on the bottom. So on my drawing, 1 inch on my drawing is 42 inches in real life. So how tall is a door that is 2 inches on the blueprint? Well, the blueprint is the scale. It's not the actual. This door is not actually 2 inches tall. But this is going to allow me to set up and find out how tall that door will be in real life using a proportion. Um, I can see that I multiplied by 2 here. 1 times 2 is 2. So I'm going to need to do 42 times 2, which is 84. So in real life, that door would be 84 inches tall, which if I use what I know about feet and inches, I can divide this by 12. That would be a 7-foot doorway. Here's another question. How tall is a window that is a half an inch? Well, let's go ahead and set up that exact same proportion. I'm going to have my scale, or the smaller information, the information from the drawing here, and the information from the actual building on the bottom. So 1 inch on my drawing is 42 inches in real life on the real building. And if the window was a half an inch tall on the blueprint, then how tall would it be here? I'd like you to go ahead and finish this problem in your notes. There is no game for this. Sorry about that. If you could find one and share it with me, I would be forever grateful.